Okay, everybody, we're going to start off a new chapter called conic sections, and I'll review what a conic section is in the next video. But for now, we're going to focus on a couple formulas that you learned in the past that we need to know. First one is the distance formula, which should look familiar. This something squared plus something squared, that actually comes from Pythagorean theorem. So you could memorize that formula, which is fine, or you could just use Pythagorean theorem, where if you have 2 points and you have their coordinates and you want to find this distance between them, let's call it C, as if it were the hypotenuse of my right triangle. And this distance is the change in x. So subtract your x's. This distance is the change in y. Subtract your y's. And we could just call this a. We could call this one b. And then you really got a squared plus b squared equals c squared. You just need to know that you plug in the change in your x's, so that how far apart your x's are on the number line, how far apart your y's are on the number line. So plug that in and square them for a and b. And then you're solving for c, so eventually you take a square root, and that's why you got your big square root around it. Or you can just do the distance formula. It's up to you. I prefer this one because it's less formulas to memorize. Okay, the other one is the midpoint formula. If you need to find the midpoint between 2 points, like if you were to connect them with a line, and you wanted to find exactly the point that is halfway between them. This point is exactly halfway between your x's. So this point is exactly halfway between the x's. It's also exactly halfway between your y's. So all you need to do to find the coordinates of the midpoint is find halfway between your x's, that's the average of your two x values, or halfway between them on the number line. And the same thing with y's, the average of your y's, or halfway between them on the number line. But please keep in mind, if the 2 points they give you are something like this, 2, 4, and 4, 8, and you have to find the midpoint, sure, you can add them up and divide by 2. Add these up and divide by 2. Or for more complicated ones, you can, what's halfway between 2 and 4? 3. What's halfway between 4 and 8? 6. There's your midpoint. Right, sometimes it's that easy. If they give you some big ugly coordinates, you just need to find halfway between them. That is mathematically their average. So add together, divide by 2. Okay, you've learned these in the past. We will need them at some point now, today, and later in the chapter. So let's talk about our new stuff. What is a circle? Okay, today we're focusing on circles. A circle is defined as the set of all points in a plane or two-dimensional surface that are equidistant, so the same distance from a given point. So here's my given point called the center, and if I choose a distance, like say the radius, right? So if that distance is my radius, every point that is a radius away from the center is the circle, and the set of all possible points defines a circle. Okay, so there's your definition of a circle. We don't need to get too into that. But how do we define an equation for a circle? Well, if I pick an arbitrary point, x and y, and for now, let's just let the center of our circle be at the origin. Okay, if I kind of drop down a perpendicular here, the distance in the x direction here is actually the coordinate of x, right? So if this is 5, this distance is 5. This vertical distance is the same as y, right? So if this is up at 8, then our distance would be 8. And if you notice what we've just formed here, it's a nice right triangle. So this might ring a bell, some formula with right triangles and lengths. We even just talked about it. A squared plus b squared equals c squared. Well, what if instead of a, b, and c, we used x, y, and r? This is the basic equation of a circle centered at the origin. So there's a slightly nicer version of that written up. X squared plus y squared equals r squared. Now, what if it's not centered at the origin? If we move our center to some arbitrary point h, comma, k. What if our center is now at hk instead? We have a generalized form that looks like this. We're back with our h and k. You might remember them from a, h, and k, but now we don't have an a for these problems. So h is the x-coordinate of the center, k is the y-coordinate of the center, and notice again it does have these minus signs, so when you plug them in they will look like the opposite sign. Equals the radius squared, not the radius, the radius squared. Okay, so the center of your circle is located at hk, and the radius is r. Okay, so let's find or identify the coordinates of the center and the length of the radius of these three circles. Okay, for A, I see my h value here, remember kind of being the opposite of what they look like, is actually positive 6. My k value is negative 7. And remember that 16 is equal to the radius squared. So to get to the radius, you need to square root both sides. And because the radius is a length, we are only interested in the positive version. So the radius is 4. Center at 6, negative 7, radius 4. Okay, B, here my h value is positive 2. Notice there is no minus value, and so just like the original that was centered at the origin, if h and k are 0, you would just write x or y squared. So in this case, k is actually 0. So 2, 0 is the center. And remember that 3 is equal to the radius squared. So when we square root this, the radius is the positive square root of 3. And we can't simplify that expression, so we'd leave it there. Last one, well, let's see, h is going to be negative 12. Again, kind of the opposite sign here. K is just positive 25 fourths. You can leave it as a fraction now since we're not graphing. If you're graphing, maybe going to a decimal is better, but this is fine. And the radius squared equals 12. Well, when we square root this, the positive square root of 12, we can simplify that. That's 4 times 3. And so that simplifies as 2 times the square root of 3. So there's my center and a radius of 2 times the square root of 3. Okay, let's try some of these backwards. Write the equation of the circle described. So here they're giving me h, k, and of course r. So if we go to our generic form of the circle, which I'll just write once here, x minus h squared plus y minus k squared equals the radius squared, we just need to substitute in, and all we need for the equation of a circle is the center and the radius. So let's plug in. We got x, remember it will look like the opposite sign here, so plus 7 squared. That positive one with y will look like minus 1 squared. And remember, if the radius is 6, in the formula, it equals the radius squared. So the radius squared is 36, right? If r is 6, r squared is 6 squared, or 36. So there's our equation of the first one. All right, let's try the second one here. All right, so again, plugging in, we'll just follow the formula from here. We've got h, we've got k, we've got the radius, we have all the information we need. So this should look like x minus 3/2 squared, y plus 1/2 squared, and if our radius was the square root of 7, well, to get to the radius squared, we need to square both sides. And the square root and square essentially cancel each other out, or you could do that times itself twice and get square root of 49. But the square root of 49 is 7. Oops, sorry, r squared is actually 7. So that is the equation of our second circle. Okay, let's try one more like this, and then they're giving us a more challenging one here. So try F out, see if you can write this one. I'll put the answer up in a second, and then we'll do G together. All right, the correct equation is x squared, because h is 0, plus y plus 2 squared. And when you do 2 root 5 times itself twice, you get 4 root 25, which is 4 times 5, or 20. The radius squared is equal to 20. Okay, this last one, not the very last one for our notes, but last one in this section, 2 endpoints of a diameter. Ooh. So all I know is if I have a circle, 2 endpoints of a diameter with these coordinates, -2, 8. I don't care that they're nowhere near accurate. Here's a diagram, right? But if this is a diameter, I know that it goes through the center. So let's see, remember to write the equation of a circle, I need the center and the radius. Well, where can I find the center? Because these are each radii, it's exactly halfway between them. I need the midpoint. That's where we needed our formula. So if you remember the midpoint formula, we just need to find the average of our x's. So add them together, divide by 2. And the average of our y's. Add them together, divide by 2. So I'm writing it like a coordinate point because that's how our center will look here. We can go ahead and start even calling this the center. This becomes +1/2, and this becomes 4/2, which is 2. So 1/2, 2. There's our center. Let's now see if we can figure out the radius. So 2 ways of doing that. I could find the distance between my center and one of these points, but I don't want to work with the decimal or fraction. So let's just find the distance between these two, which would be the diameter, and cut it in half. So let's find the distance between these two. You're welcome to use the distance formula. Again, I kind of stick with Pythagorean theorem here. So the distance we're trying to find here is c squared. A is how far apart are 2 and 3 on the number line. Now you can alternately subtract them in that order, but from -2 to +3, those are 5 units apart. So I'm going to plug that in for A. From 8 to 4, how far apart are those in the number line? Well, I'd have to go down 8 to get to 0, 4 more to -4. Those are 12 units apart. And now I'm solving for their missing diagonal, the hypotenuse C. So this is the distance formula, but with Pythagorean theorem. You're welcome to go back and use the actual formula. You should come up with the same answer. And you might even recognize this one. Like if you remember your Pythagorean triples. Because when you do the square root of this, and we're only interested in the positive case because we're talking about a distance or length, it's the good old 5, 12, 13. Oh my goodness, the diameter is 13, which means the radius is 6.5. We have our radius, we have our center, we can now write the equation of our circle. Finally, x minus 1/2 squared plus y minus 2 squared equals, now I do need to square 6.5. All right, we have one last thing we have to do. There is some really ugly form we'll see conic sections in that looks like this. It is called general form. It looks disgusting. What we want is standard form. Okay, standard form is like this. We get to see the center and all the important information. So how do I turn this into something that looks like that? Well, notice we need to create these quantities that are squared. And we do that through the process called completing the square. You may have done this in algebra, or you should have done this in algebra at some point, and it's back. Not only are you going to complete the square once on this thing, if I have an x squared and x to the first, we have to complete the square for x. If we have an y squared and a y to the first, we also have to complete the square for y. We have to create both of these quantities. If, and the real if is if this kind of linear term, like x to the first and y to the first are there, then we got to do both. So how do we do that? Well, the first thing is I like to move the constant to the other side. So subtract that 28 over. Get out of here. Okay, next up, we're going to pair some stuff up. Let's pair up x squared and our term with x. So we're going to write these way off to the side here. X squared minus 2x. And if you remember completing the square, we add a blank on each side that will make this a perfect square. We'll come back to that. Next, let's combine or pair up our positive y squared and negative 12y, plus, again, a blank, because we'll need to complete the square. Okay, equals negative 28, which is now what we have on the right, but don't forget we need to do plus blank for our x's and plus blank for our y's. Two new values we need to add to each side. So, quick review. How do you complete the square? To complete the square for a quadratic, you need to take the middle term, which is usually called b, right? Think of quadratics like ax squared plus bx plus c. It's kind of the standard form. So that term with x to the first is usually b. It's half of b squared. Half of b squared. Half of the middle term squared. So what is half of negative 2? Well, that's negative 1. And when we square that, we get positive 1. It's always a positive value when you square it. That's why it's always plus here. But we need to add 1 to both sides. So I'm going to do that in blue. Let's go ahead and add 1. That's the value that completes the square for x. Okay, let's go ahead and do the same thing for y. What's half of my middle term, half of negative 12? So we divide it by 2 and square it. Half of b squared. So half of negative 12 is negative 6. Times itself twice is positive 36. So we need to add positive 36 to both sides of our equation. Again, if you add a new value on one side, you have to add it to the other to keep your equation balanced. Okay, now what we did though is we created something that's going to factor as a perfect square for x. And here is the shortcut. You need to know the shortcut to make this chapter easier on yourself. This, when we factor it as a perfect square, the perfect square we always create will either be x or y. I'm just going to use x in the example. Plus or minus, depending if it's positive or negative, half of b. Half of the middle term. So what's half of negative 2? Negative 1, x minus 1 is that perfect square we just created. Other shortcut here. What's half of negative 12? Negative 6. So y minus 6 squared is the other perfect square we just created. Now on this side, we do need to add these up. Let's see, 37 minus 28 is 9. And check this out. We did it. We are in standard form. And now I could tell you lots of things about this circle, like its center is at 1, 6. And if this is my radius squared, the square root of 9 is 3. My radius of that circle is 3. Okay, so let's repeat the same process here for I. So first thing we're going to do is move the constant to the other side. Get out of here. And then let's pair up our terms with x. So I do see an x squared and a minus 20x. So x squared minus 20x plus blank, so we can complete our square. Let's go ahead and pair up the stuff with y. I got just y squared. Notice there's no y to the first power. That actually means we don't need to complete the square for y. That's nice. So we really only need to complete the square for x. So we're going to have our negative 91 plus blank. Well, let's go ahead and complete the square for x. Remember, half of b, half of negative 20 squared. So half of negative 20 is negative 10. And negative 10 times itself twice is 100. So we need to add 100 to both sides of the equation. Okay, now remember, we just created a perfect square here with this expression for x, and it factors as, what's half of b? Negative 10. X minus 10 squared. Now remember, we didn't have to complete the square for y, so that's just plus y squared. And adding 91 and 100, that's a 0, we get 9 yet again, coincidental there. But check it out, this is in standard form. The center of my circle is at 10, 0, right? That's actually our k value there. And if the radius squared is 9, then my radius is 3. Okay, here's one last one. Here's one for you to try out. See if you can complete the square twice. Kind of follow H here, and I'll put the answer up in a second. This is the last example. All right, There we go. If you paired everything up correctly, found the correct values, remember half of b squared to complete your square for each, and add them to the other side, we end up getting positive 4, and these are your perfect squares. So we get a circle with center at 7, 3 and radius of 2. Now this completing the square is not going away. In fact, in our other sections, we're going to be doing a more complicated version of completing the square. So you need to know how to do this and get good at it. So make sure you practice this. If you have questions, make sure you ask now. See you in class.